Hello, we are here for one more lesson of this T-FLEX analysis training course. And the topic for today will be the steps of frequency analysis. Let's enter with a little more detail about this different type of analysis. With that purpose, I've prepared, to avoid losing too much time with this, I prepared a simple model. And this one in particular, you can see the video of this element in one of our examples. But let us go through a couple of steps that are necessary steps to create an analysis of this type. So this is performed as all the other analysis in several stages. The sequence is very similar to what we described for the static analysis. So it will be something not too far away from what we talked already. So the idea here is, first step is to create a study. In this particular case, I already created, but basically inside analysis menu, create a new study. When you go to the new study, we have to choose this frequency analysis. I will not do it now, it's already done. Then we need to apply boundary conditions. And the boundary conditions on a study of this type are solely defined by restraints. It is necessary that with the elements or the structure that is subjected to this type of analysis, a model must be restrained so that we can exclude its free motion in space as a solid body. If we fail to meet this condition, then we will have incorrect results, or probably we will not achieve a calculation. So we've already applied, we have here, you see a partial restraint here, a partial one in here, and a full restraint on the other face of this element. With all these conditions, we need to go to the solving, as simply as that. So we have all these methods and these options we will see in the next video. We can calculate the number of frequencies, let us say 2, for example. Let us calculate without taking too much attention on the parameters that we will leave for the next lesson. And basically we got results. We got 2 frequency modes that we will show you something like this, frequency mode 1 and mode 2, so something also like this. But basically the results that we can get of this type of analysis are 2 different things. First, the natural vibration frequency in Hertz that corresponds to the expected resonant frequency of the structure. So in theory, we have natural frequencies, we have unlimited number of frequencies for any type of body. Besides this natural frequency, we have natural vibration modes in respect with the given frequency. So we have the frequency and we have the mode which correspond to this pattern of motion. And in this particular case, if we do an animation, we see that we have a certain type of pattern in terms of displacements. So this is basically what we can get with this type of analysis. Any question, any help that you may need about these concepts, let us know.